On this part of physics, we are going to talk about photons of light and photoelectric and the related points like threshold frequency and work function. So what is the photoelectric? Photoelectric, if I have here a plate of sensitive metal, when light is coming here, this is the light, when the light is coming into this plate, what will happen? If this metal is sensitive to light, what will happen? As we know, inside this plate, there are billions of atoms, and each atom here, if you move deeply to it, you're going to see its nucleus, and around it what? Electrons. And these electrons are moving what? Or rotating on shells. Okay, now each electron has energy, and this energy, it gives it a chance to rotate on a specific shell. Okay, what would happen now if we give this electron more energy? This electron now, if we give it more energy, and this energy has to be specific, has to be quantized. That means if we give it the difference energy between this shell and this shell, exactly this amount of energy, it will take this electron from the lower level into what? Into higher level. Okay, if we give it much more energy, the energy that the electron needs to be ejected out of this atom, the electron will be ejected. So light is photons. By the definition of Einstein, then, light is photons. And these photons are packets of energy. Are packets of what? Of energy. So the light contains packets of energy. And each light, as we know, it contains different colors, and each color has different frequency to a different what? Energy. So these electrons, now that they are here on this plate, if this plate now, as we said, metal that is sensitive, when the light is coming now, that means energy. So these energy now, it will come to these electrons, it will give them enough energy to be ejected out of the metal. So these electrons now, when they are ejected out of this plate, we connect just the plate here with wires, and we put here either a battery or a bulb. So this flow then, this flow of electrons now, it will flow through the wires. So that means, as we know, electricity is a flow of electrons. So when these electrons, when they flow, they give us what? Electricity, and this is what is called photoelectric. That means the relationship between light and electricity. So light can give us electricity. How? When we use a plate that is sensitive to light, and this light now, when it comes to this plate now, electrons are ejected from their what? Atoms. Then when they are ejected, they move through the wires, and movement of electrons, it means movement of charges through the wires. This is what? This is electricity. So you understand now, but we understand now what is photoelectric. But the question is, when do electrons are ejected? Is any light, any type of light, red light or green or blue, is able to eject these electrons? And does it happen with any metal to be the plate? Then these electrons will be ejected. These ideas that we are going to concentrate here. So look, by the definition or the energy of photons, we said the energy of photons are quantized. That means it is quantum. That means it has a specific numbers that are multiple of what? Of a number that is what? HF. What is H? H is a constant, and F is the frequency. So for example, now if we are talking about red color now, it has energy. So when you just start a light that is red towards a metal, that means now this direction or this movement of red color, it contains what? Energy. Okay, what is the magnitude of this energy of the red light? The energy of this red light, it equals H times F. What is H? H is Planck's constant, and it is a number that is what? Constant. And what is F? F is the frequency of red color. And as we know, the light is electromagnetic waves, and all these electromagnetic waves, either radio waves, gamma, X-ray, light, all of them, they have different wavelengths, and based on that, they have different frequency. So each light now, each color of the light has different frequency. If you multiply this frequency by the H, you will get the energy of what? Of red color light. Same thing when you make it with what? With blue color. Blue color also, it's gonna be E equals what? H times F. F is what? Is the frequency of the blue color. Okay, now, as you see, H is constant here and here. In both equations, it's constant for the red color and for the blue color. Now, which one has higher energy? The red color or the blue color? As we know, since the H is the same for them, so it's not considered. So that means we consider just what? The frequency. Which one has higher frequency? Blue has higher frequency. When blue has higher frequency, that means it will have higher energy. So all the colors, they have different frequencies, and based on different frequencies, they have different energies. And when frequency increases, energy increases, because the relationship between energy and frequency is directly proportional. And also, as we know, there are another formula that is the speed of light. It equals wavelength times frequency. And based on this formula, wavelength and frequency are inversely proportional. What does that mean, inversely proportional? That means if one increases, the other one decreases. So as you know here, for the red color, the frequency of the red color is lower than the blue frequency. So for the blue frequency, the frequency is what? High. But here now, what will happen for the wavelength? Wavelength is the opposite. So the wavelength here of red is higher than the wavelength of what? Of blue, which is what? Down. So that means when the frequency increases of any color, of any light, when the frequency increases, the energy increases. And when the frequency increases, wavelength decreases. This is the relationship between energy, frequency, and wavelength. And I hope it's clear. But now the question here, as you see, red color now, it has energy that is what? Which is HF. And this HF is a number. And any other energy for any color, for any other light, it has to be multiplied or a multiple of this number. So that means here has to be a number that is what? Called N. So that means E, it can be written NH what? F. And when N is 1, this is the smallest what? Quantum of energy. Okay, so this one has to be integer, either 1 or 2 or 3 or 4 times this number. So any energy now, it has to be a multiple of HF. That means multiplied by integer, which is F. Okay, now we'll ask a question now. If we have electron here on the middle here, this is now we have electrons. As we said, we have an atom and around it what? Electrons. These electrons now, they need a specific type of energy, specific quantum of energy in order to be ejected out of their electrons. Okay, these energy now, will it be the energy of red color or of blue color or of ultraviolet or infrared or what wave of energy? So now it depends on what? When do electrons are ejected from the surface of a sensitive metal? Again, here we have, as you see, these ones, as we said, atoms and around them electrons, and the goal is we need electrons to be what? Ejected out of this metal in order to have a flow of electrons. That means to have electricity. So when light now here is on this metal, the least amount of energy needed to eject the electron is called work function. So what is work function now? What is the work function of the electron? What is the work function of electron of any metal? The work function is the least amount of energy needed to eject the electron out of its atom. So you understand now as what? As energy. So work function is what? What is it? It is energy. It is the least amount of energy that the electron needed to be ejected out of its atom. Okay, if we give now, if the work function of energy equals, for example, 5, and we use the unit here electron volt for energy. We use what? Electron volt. Okay, if this electron now, its work function, that means its minimum amount of energy needed to be ejected is 6 electron volt. Now, when I send this light now with 5 electron volt, will this energy be enough to eject the electron of the metal? No, it will not be enough. Why? So electrons are not ejected out of their atoms if the energy of photons are less than the work function of their R. So that means the work function now to eject the electron is 6. That means if you give it now 5 as energy, it will not be enough to eject the electron. Okay, what about now if we give it another light with energy here, for example, 6 electron volt? Will this electron be ejected out of the atom? Yes, it will be ejected. So if the electron receives energy that exactly equals the same work function of its own, in this case, this electron will be what? Ejected. What does it mean ejected? That means it is now rotating in levels. That means it will go out of the level of what? Of the atom. So that means if it receives a photon of energy that equals to its work function. Okay, now what would happen on the third case if we give it a photon that its energy is 8 electron volt? We give it to this electron. What will happen? Will the electron be ejected? Yes, it will be ejected. Okay, it will be ejected by using 6 electron volt out of this energy. What about the 2 extra electron volt? It will be changed into kinetic energy. So the electron now, if its work function is 6 electron volt and it receives 8 electron volt as energy, it will use 6 electron volt to be ejected out of the atom. And the 2 remaining, it will use it as kinetic energy. So that means this electron now will be ejected out of the atom, and also it will have 2 electron volt as kinetic energy. That means it will keep moving by the energy that it has. So that means if we give the electron energy less than its work function, it will not be ejected out of its atom. But if we give it same energy like its work function, in this case the electron will be ejected but will have no kinetic energy. But third case, if we give the electron more energy than its work function, in this case it will be ejected and it will have the extra energy as kinetic energy. So that means now, this case, if we are talking about energy and work function. Okay, what about, as we know, the energy now, it equals H times F. That means the constant, the Planck's constant times the frequency. Okay, so this one now, this energy is, we call it what? Work function. Okay, work function now, we can set the least amount of energy needed to eject an electron out of its atom. Okay, the energy itself, it depends on what? It depends mainly on the frequency of what? Of the light. It depends on the frequency. Okay, this frequency now, that means we have least amount of frequency because the frequency now, it controls the energy. So what made the energy called work function? The frequency. So the number or the amount of frequency, it determines whether this energy is the work function or less or greater. So this energy, this frequency now, if the frequency is the least frequency needed, we call it threshold frequency. We call it what? Threshold what? Frequency. What is threshold frequency? It's the least amount of frequency needed to eject the electron out of what? Out of its atom. So that means we can say that we can use the energy, the least amount of energy used to eject the electron out of its atom as work function, if we are talking about the energy. If we are talking about the frequency, the least amount of frequency is called what? threshold frequency. So threshold frequency, which is F naught here, if we multiply it by the H, we get what? The work function. So frequency is the main factor in determining the amount of energy of a photon. And we understand that if the threshold now, that means each electron here it needs, if we are talking about threshold, that means the received threshold, it has to be greater than the threshold of that electron in that metal. If we are talking about work function as energy, when the frequency is multiplied then by H, we are talking about what? Work function, that the work function has to be equal or greater than the energy of the photon, it has to be equal or greater than the work function of each metal. I hope now you understand what's the difference between work function and threshold frequency, and we understand energy equals what? H times F, and we understand that each color of the light, it has its own energy, and each energy is different from one color to color based on the frequency of that color, and each color has a frequency and has a wavelength, and the frequency with the wavelength, they are inversely proportional, while the energy and frequency, they are directly proportional. Okay, do we use these things in our lives? Yes. So electricity that depends on the sun, on the light, we call it what? Photoelectric, and it works based on that. So that means not any metal, we can use it to give us what? Electricity. We use this as sensitive metals that are sensitive to the light that are coming from what? From the sun. And also we use them in the auto doors, those doors of the malls, of the hospitals, that when you approach next to the door, it gets opened by themselves. Why? Because it depends now on the light. When you go to the door, that means you are closing the light towards that sensitive sensor there. So that means you are preventing the movement of electrons. In this case, the door gets what? Open. Okay, questions based on that, they're going to be solved on the quiz.